All right, everybody, let's take what we know about vectors and apply it to a word problem. So in this problem, we see that two horses pull a cart due east. The first horse pulls at 300 newtons, 15 degrees north of east. The second horse pulls at an unknown force, 20 degrees south of east. And what I want to know is the vector sum of these two forces. So let's start by maybe drawing a picture. That's always a good place to start. So I have my horse, and I have two vectors acting on the horse. So one is a 300 Newton force, and it has an angle of 15 degrees. The other is an unknown force, but it has an angle of 20 degrees below the horizontal. I'll just put an F there as a symbol. And what we're asked to find to solve this problem is, what is F at 20 degrees south of east? So we could say negative 20 degrees, or we could say 340 degrees, or we could say the other. So I'm going to put 340 degrees for now. Plus 300 newtons at 15 degrees. Okay, so to begin to solve this problem, I see that I already need to find what F is. So how am I going to do that? So this is like an intermediate step, and this is why having a plan is so important. So first we need to know what the problem is asking. What is F plus 300 newtons with their respective angles? And then we're going to devise a plan. So what plan could we devise? Well, we know the vector sum is all east, which means there can be no north or south elements. So the y components have to add to 0. So we can use that piece of information to begin to solve the problem. So I know that I could call this total vector sum, we'll say t. And I could say that ty has to equal 0. And that would be 300 newtons sine 15 degrees plus F. And I could either say sine 340 degrees here, which is one way to approach this problem, or the other one is I could put a minus sign there because I know my y component here is negative, and I could just use the sine of 20 degrees with a negative sign. So either one of those ways is a fine way to approach the problem. So that's what I'll do, and I'll say that, well, I know it's a negative, not a positive, because my component here points down. And then I'm just going to go ahead and put sine 20 degrees. All right, now all I have to do is solve for F, and that gives me my starting point. So how do I do that? Well, I add F sine 20 degrees to both sides. Then I get F sine 20 degrees has to equal 300 sine 15 degrees. Then I divide both sides by sine 20 degrees. All right, so now I can say that my unknown force, F, is equal to 300 newtons sine 15 degrees divided by sine 20 degrees. And when I do that, I get that F is 227.0 newtons. All right. Now I can find the x sum, which will be my total sum, and I can say that, well, Tx has to be equal to, well, let's see, 300 newtons cosine 15 degrees plus 227.0 newtons, and then I can put cosine 20 degrees or cosine 340 degrees is the same value. So I'm going to put cosine 20 degrees because I know that I have a positive x component here. So when I'm worrying about sine, sometimes I have to look at my picture and take care of this myself. So if I see here, I know I have a positive x and a positive y here, and I know I have a positive x and a negative y here. So if I'm going to use this 20-degree value, I have to take care of that sine in front of my components by myself. Or I could just use the same reference angle and put, say, a 0 degrees here, call this 15 degrees, and then the other one, instead of looking at this angle, I'd have to look at this big angle, which would be 360 minus 20 degrees. So when I plug this in, I get 503.1 newtons east. And if I want to double check myself, I can come here and I can go, okay, well, Ty is equal to 300 newtons sine 15 degrees minus 227.0 newtons sine 20 degrees. And if I put that in my calculator, I get about 0. So my total force, net force here, has to be that 503.1 newtons. And to solve this problem, I had to do an intermediate step where I had to use the fact that I knew that the north-south component of my vectors had to add to 0. I hope that was helpful and allowed us to look at a word problem that's a little bit trickier involving vectors.